In this video, we're going to be taking a look at MPLS timers. When it comes to MPLS timers, we're going to have to take a look at just the basics because that's pretty much all we're going to get tested on in the exam. There are a lot of other timers that are available to us that pretty much just plain old fashioned fall out of scope in terms of what we're going to get tested on. So we're going to take a look at just the basic timers and what they are and how they work. Now, because LDP is a label distribution protocol, it relies on timers just like OSPF and EIGRP do. So it's important to understand what those values are and how they work. So we're going to go ahead and configure them just so you guys can see what they look like. Very, very basic stuff, but it's important to know, obviously, what they are, their values, and how to configure them. So the hello interval is the interval that hello messages will be sent. So every 5 seconds by default. Okay, so pretty standard stuff. The hold timer is the value that if no hellos have been received, the hold timer will expire. This means that you can send 3 hellos. If you miss 3 hellos, which is 15 seconds, then you're going to go ahead and take down the adjacency. Every time a hello or LDP message is received, hold timer is reset. Now, you might say a hello or LDP message. What's the difference between the two? Well, let's talk about that for just a moment. If you were to debug the MPLS LDP transport events, you're going to see a lot of, it's a pretty noisy debug, but basically, because the hellos are sent via UDP, and LDP messages for like label advertisement and other things are sent via TCP, there's a couple things we have to take into consideration. So if I'm going to be sending hellos, now there's 2 different types of hellos. You have the directly connected hello, and then you also have the targeted LDP hello. Now the difference between these two is the directly connected hello is going to be the one where I obviously am physically connected to my next hop. So whether that's, in our case here, it is a simulated point-to-point connection between, say, R1 and R2. Where that could be between R1 and R3. So like for instance, we have session protection turned on, and as long as the primary connections are up and running, you're going to form a targeted LDP session to that peer via another path, right? So the hello timer is gone out via UDP as a directly connected setup. Now, the other aspect of this with the targeted LDP is that is point to point, but it's multi-hop, just like an eBGP multi-hop connection would be. Very similar in nature in our design here. So one of the key things we have to take a look at is if I'm going to be taking the data and I'm going to be sending hello messages, that's UDP, okay? Where the LDP messages are typically going to be TCP. This could be any type of information that you could receive. This could be just a regular refresh packet. It could be anything. As long as it's got LDP, the protocol is LDP and the actual transport, then we know we're good to go. So those are the 2 different differentiating aspects to the hold timer. Then we also had the back-off timer. The back-off timer is basically if you can't agree on your LDP parameters, you're going to go ahead and just not form your peering adjacency. This would be similar in the case where, like, for instance, a parameter would be like a password. If I'm going to be setting up TCP authentication, using option 19, I could be doing something along those lines. It could be now, those are going to, we'll test out a couple different variations to see which ones actually click, because I'm sure there's a list published somewhere. I haven't looked one up yet, so we're going to test a couple different theories out. Disable authentication, enable authentication, things like that. For the majority of the time, this is going to be your hello and dead interval, kind of like OSPF. So that's where I would reference this from. But at the end of the day, we'll take a look at a couple different variations. We'll just, for a very basic look at it, we'll just modify the hello and hold timers and see which ones trigger and stuff like that. Where we'll see exactly which ones kick into play here. So from a command line perspective, we're going to go ahead and jump in this. We're going to start off between R1 and R2. And the reason why we're going to do that is because we don't want to affect normal forwarding for anything else. So we're going to go ahead and pull up to our Super Putty, and as you can see, it's not going to be too too complicated to do this. So from global config on iOS, we're typing MPLS-LDP discovery question mark, and you have the hello, and you would specify either the interval or the hold down. So we're going to specify the interval, which is how often you send it. Now, one of the things here, we're going to do a show MPLS LDP discovery question mark, and we're going to hit the enter key. Now, if you look right here, all you see, and this should be a familiar output from our IGP LDP synchronization. So and our system protection. So we actually have to be a bit more specific and type in detail, and we have to hit the enter key. Now, where I want to focus right here is this up here. Now you see the hello interval is 5,000 milliseconds. Well, a quick calculation of that is going to be what? 5 seconds, right? And then you have the hold down time, which is 15 seconds. So those are the default values, like I have illustrated in my slide. Now we can go in here and go to global config and type in MPLS LDP discovery is going to be the hello interval, and we're going to specify that it is 3 seconds and hit the enter key. Okay, so that's pretty much all there really is to that. Now, with that being said, we're going to go ahead and say that the hold time here we're going to say is 9 seconds. Pretty straightforward stuff, right? So that's the basic breakdown to that. Now we jump out here to show MPLS LDP discovery detail, and you'll see that we are at 3 milliseconds and 3,000 milliseconds or 3 seconds, and the hold down time is 9 for the hold down. Go back up here. We also have the back off timer, which is similar in configuration, but we have to specify the LDP back off, and then the back off timer here is going to be a different situation. So we're going to have to, I have to actually hunt that one down. I'm not exactly sure where that one is visible. I want to say this is going to be in, back off. Actually, I'm sorry. Show MPLS LDP back off 15 and 120. So 15 seconds and 120 seconds for the maximum. Once we say all, okay, so it's basically the same output. So we're going to go to global config, MPLS LDP back off, and we're going to specify for the initial back off timer, we'll say is 5 seconds, and then the maximum we'll say is 15 seconds. Okay, so show MPLS LDP back off 5 and 15. So we have that. So we do a show MPLS LDP neighbors. We should still have a peering to all these other guys. Now it doesn't specifically state in here who or how often we're sending data back and forth, just the fact that we are. So we do a everything's up and running. You know, there's still show MPLS forwarding table. We still have active adjacencies, and everything's working the way that it needs to be. So our timers really haven't changed a whole lot. So they are a local adjacency. So if they don't agree on other parameters, we could go in there and manipulate, like obviously like authentication. That's going to be one of those things that we would obviously have to match. So that's pretty much the timer values, as you can tell.